So why don't we get started? So for the next part of the session, what we're going to be doing is giving some presentations for perhaps some of our newer users. We're starting with Luigi Marini, who's going to talk about basically give an overview of Clowder, going over some of the design principles driving it, why certain decisions were made, and so forth. So let me hand it over to Luigi Marini, software architect for Clowder.
Welcome to the Clowder overview. In this session, we'll review basic Clowder features and what makes Clowder unique. So, why Clowder? What problems does it try to solve? To answer this question, we'll take a brief look at how it came to be. Before Clowder, NCSA was developing a system called Medici. You can think of it as a precursor to Clowder. Many of the Clowder concepts were developed as part of Medici. It was in development at NCSA between October 2009 and October 2013. Its main focus was on storing research data, which is usually characterized by a variable amount of bytes in any format and a variable amount of metadata attached to it. It stored metadata as RDF using the tuple middleware, also developed at NCSA, and had a friendly web interface to interact with it. As we were developing Medici, we started applying it to a variety of use cases, from digital humanities to hard sciences. We incrementally started adding features, and the system slowly became something more. We started visualizing data in the browser, adding social annotation capabilities, automatic execution of code on data ingestion, and more. At some point, we realized that the system was doing more than just storing data and metadata. The way it was originally architected did not make it easy to scale to big data and cloud resources, which, at the time, were both becoming increasingly more common. So, based on lessons learned, we started from scratch. Clowder was Medici 2.0. But we're still bound to the curse of too many projects with different requirements, coming and going, of different sizes, with different priorities. Hence the name Clowder, a cluster of cats. It sounds like cloud. We started making little puns, such as data catalogs in the clouds. And we thought it was funny to think of a bunch of cats getting along, just as we struggled to support so many requirements from so many different projects, sometimes conflicting. But everything we did was with the goal of supporting data curation for research. One constant was that we were developing many instances for many use cases. This meant managing and customizing each instance separate. This need became a core aspect of Clowder. NCSA maintained many project instances using project-specific funding. In recent years, we have been incredibly excited about instances being set up and maintained by others, and are looking forward to learning more about those during this All Paws and supporting any new ones that might arise in the future. We want this process to be as easy as possible. Let's take a closer look at what Clowder can do and why it works the way it does. As already mentioned, Clowder came to be incrementally based on projects it was being developed on. This will be a high-level overview. The Clowder user demonstration session will show specific examples of the features described here. The core of the Clowder data model is the dataset, which, in the case of Clowder, is a bunch of files and metadata, plus folders, tags, comments, visualizations, license, and more. By default, the dataset is private to the user who creates it, but it can be shared with other users within the Clowder instance using spaces, and it can be made public to the internet for those who do not have an account on that Clowder instance. Datasets can be downloaded and uploaded as zip files, using the standard Baggit metadata format, popular with libraries. Clowder does not care what kind of files are uploaded to it. It tries to guess a MIME type, and based on that, it might or might not have extra features enabled. Behind the scenes, Clowder can store these bytes in a variety of backends. The two most common ones, the file system, usually an NFS share, and AWS S3 buckets, which can be used locally with MinIO. Developers can easily add new implementations using a service model within the Clowder core that lets developer change what backend service Clowder relies on. For example, this information is by default stored in MongoDB, but if one wants, they could implement a different backend, for example, Postgres. Attached to the files and datasets is a very generic way of storing metadata as JSON linked data documents. The linked data approach follows in the semantic web technology roots of Medici. The JSON format makes it easier for users who are not familiar with linked data to still have uniquely defined and portable metadata in a format ubiquitous to the web. This is very similar to the schema.org approach. This metadata can be specified by users within the web UI or a web API, or by a machine, a custom client, or an information extractor. More information on this to come. Furthermore, it is all portable and accessible from the web API. The content of each metadata document can be an arbitrarily deep JSON tree. See the examples bottom left. The add context element specified what each key in the content is as a unique URI. This usually comes from an existing standard vocabulary ontology or a custom one. Clowder also stores basic information about the creator of the metadata document, such as which user or information extractor created it and when. Anyone with the proper permissions can add more metadata to a dataset or file, resulting in a form of social curation of metadata. Any metadata stored in the system, including descriptions of datasets, files, comments, tags, etc., can be retrieved using the search interface. This also includes new metadata fields added by clients and extractors, and not currently known to Clowder. Another major aspect of Clowder is its ability to support custom information extraction steps, what we used to call metadata extractors. Originally, these were used to extract metadata from a single file, and add previews to large files so that a user didn't have to download gigabytes or terabytes of data to get a sense of what was in the file. Eventually, this functionality was extended to many other events, such as when metadata is added to a file or a dataset, and even the manual submission of files and datasets to the extraction bus, so that data analysis tools, AI models, and more can be executed on these files and datasets. Extractors talk to the web API, and as such can create all sorts of derived information, create new datasets and files, add new metadata, previews, link resources, etc. Any code can be embedded in an extractor, and the use of containers simplifies this process. Extractors were the first component of Clowder to be containerized as Docker containers and scaled to large loads. The rest of the framework was then containerized as well to simplify deployment. Please join the Clowder extractors and how to create a new extractor sessions, day 2, to learn more about extractors and how to create them. The other major aspect of Clowder that was developed organically over time as more use cases presented themselves was the idea of data previewers, a feature that we believe to be somewhat untapped and we hope will receive more attention and interest from the community in the future. Originally used to provide smaller versions of files to stream to the browser and different versions of files that can be natively played in the browser, for example MP4 for videos, it is now also used to provide interactive visualization of the data, for example geospatial layers overlaid on a map. It could also be used for adding information to the file. For example, in the case of an image, the image previewer lets users select a portion of the image by clicking and dragging, and then add a tag and comment to that section that gets indexed like any other tag or comment on a file. All it takes to create simple previewers is the knowledge of basic JavaScript. As it is with extractors, any web API endpoint is available to the previewer. Please join the data previewer sessions later today, day 1, to learn more about previewers and how to create them. Together, user and machine created JSON-LD metadata, custom information extractors, and data visualizations allow Clowder to support any data type as part of a typical research data management activity. So, being native to the web, Clowder was always meant to simplify the sharing of research data. Let's see how it currently does so. For a dataset to be accessible to other users, it needs to be shared with a space. Spaces offer a dedicated location within a Clowder instance for specific research efforts. Any user in Clowder can create any number of spaces and add any number of collaborators to it. Spaces can also be customized with some simple info, including a banner and logo. When a user is added to a space, they're given a role that defines what they can do within. The default roles are admin, editor, and viewer, but new ones can be created. For private spaces, users can request access, and admins can invite new users to it. Currently, spaces offer the only way to privately share datasets with other users of the system. Clowder instances by default provide local management of users and credentials, but over time, we have added different methods to single sign-on. In particular, we want to highlight CI logon, which includes support for shibboleth and in common, and as such makes it easy for Clowder instances to support existing research communities, universities, and labs, without the extra need to create new user directories. That being said, by default, users who sign up with a single sign-on still need a Clowder admin to enable their accounts before they can gain access to that instance. While we're on the topic of spaces, we should mention collections, something that looks similar to spaces, and folders within datasets that often create some confusions. Collections are collections of datasets and nothing else. They can be thought as a museum collection, where different standalone works or datasets are collected together by curator, the owner, as they're related in topic. Unlike datasets, they currently don't support generic metadata and visualization, even though there has been some talk to add both. The full picture of the Clowder data model looks like this. Datasets are the core object and include files, folders, metadata, and previews. Files also includes metadata and previews. Spaces are intersection of datasets, collections, users, and permissions. Datasets can be organized in collections. But the most important thing to remember is that a dataset is the core resource type. Everything else revolves around it. Let's briefly talk about customization, as that is one of the core features of the framework. First and foremost, we want to reiterate that rich metadata, custom information previewers, and extractors offer a great amount of customization. No changes to the core of Clowder are required to develop new ones. Since Clowder was developed incrementally over many projects, it offers a variety of functionality that can be enabled and disabled. This means that Clowder instances could look very different. This is all driven by configuration files accessible to the system administrator deploying Clowder. For example, starting at the top in clockwise order, you can enable having datasets in multiple spaces. Enable the ability to copy a dataset to another space. This creates a new copy, not a soft link. You can enable major new features, such as the NSF seed staging area, to publish data to long-term repositories. You can enable the ability of making datasets publicly available to anyone on the internet, and set what the default for a space is. Because the entire framework is containerized, different deployments can more easily enable specific features that might require different dependencies. This is also helpful for developers. We currently support Docker Compose and Kubernetes. Please join the Deploying Clowder session, Day 2, to learn more about containers and how to deploy Clowder. Lastly, Clowder provides an extensive JSON RESTful web API. Almost all functionality available in the web UI is available in the web API. Extractors use the web API to write back results. Projects can create custom clients specifically tailored to their use cases. Data pipelines can leverage the API for custom workflows. You can learn more by looking at the Swagger documentation at that link on the screen. For example, the NSF Brown Dog project developed an Excel plugin that could send the contents of an Excel sheet as a file to a specific extractor, to calculate the green index of a route by querying Google Street View and doing some basic computer vision, and write the results in a new sheet in the Excel file. Examples of how to use the API are available in this repository on the screen as Jupyter Notebooks. This also shows an example of how to integrate Clowder with notebooks. We hope this short overview also shows how Clowder follows fair data principles. Information stored in Clowder is findable thanks to expressive, uniquely identifiable JSON LD metadata, unique URLs for each resource. Accessible, thanks to simple JSON HTTP protocols for web services, and single sign-on using things like CI logon and social media accounts. Interoperable, thanks to the JSON LD that enables open support of any existing standard vocabularies and ontology. Reusable, thanks to the silent license and provenance information that are included with core resources. In closing, we go back to another pun around the word Clowder and cats and talk about the long tail of data. We hope you can see how, by being so flexible, supporting any data type and analytics, Clowder tries to support the long tail of data that often arises in research. At the same time, being built on best practices to scale, Clowder is being used with large datasets and together can provide support for three typical needs in research data analysis: big data, custom algorithms, and custom data formats. Thank you. Any questions?
All right. Do we have any questions for Luigi or others?
Does Clowder handle languages other than English? Yes, we have support for internationalization within the Clowder code base. We have not used this extensively. So some of the text that you see on the UI is tracked in some files that can be also translated to different languages. But we would need help for sure to make that translation. And also, yes, definitely. So we have functionality to support Spanish. We would need help with translations. And also there might be a few places in the code base where we would have to do a little bit tweaking of the code. But overall, we have support for other languages. Thank you, Gabriela. Thank you, Richard. Richard makes a comment. Good presentation. The video will be a useful intro to introduce my new manager to Clowder. Thank you, Luigi. Thank you, Richard. Yes, this might have been a little bit of a repeat for most of us, since most of us, I think, are somewhat familiar with Clowder. But the intention is to make it a very high level introduction to what Clowder has to offer. The next presentation will go a little bit into more details of this content. Thank you, Richard.
Luigi, we have one more question.
Yes, thank you, Dominic.
You mentioned Dataset as the core resource type. Is that atomic, or does a Dataset have addressable via URLs, components, elements, rows, key, values, or pairs?
Almost everything in Clowder as a unique URL. So we expose the internal UUIDs, and there's a place both in the API as well as the UI to get access to that component. So for example, every metadata document within a data set or a file will have that unique ID that you can use to just get access to that particular component. Same thing for files. So part of your question is rows and elements. In a data set, we track metadata, we track files. If there is things within a file, for example, rows, we have done what we call sections. And we've used that for two things: in videos or media that has a time component that represents time codings within the media, the file. So how many seconds from the beginning something has happened, you want to show a preview, you want to add some metadata. We've also done it for PDF documents where a page kind of gets an ID. So files do have sections, but it has only been used for these two examples. I hope that answers your question. Thank you.